Recently I've been curious about solar cells, so here's a couple of things that I've found. This one here is one of the first ones that I started experimenting with. It's a polycrystalline cell, and it's blue and it's got all kinds of little shapes on it, which is kind of neat. They're older in style. It's an older technique from what I understand, and they don't give a huge amount of electricity out of them. Basically what happens is the light hits the surface of the cell, the photons of the light displace an electron, which goes out through the wire, and then another comes back through the circuit. So the whole thing keeps going, but the light hitting it is what causes the whole thing to work. Of course, it only generates electricity if it's in a circuit. So right now, none of these cells, except for two of them, will actually generate any electricity. So this is a polycrystalline cell. Got a whole bunch of them. They're fairly inexpensive. These ones cost me $1.50 with the leads, the tabs soldered onto them. I also have a whole bunch of this tabbing wire, which was kind of handy to have. These other ones here I got from the same place. There's got a whole nice little stack of them. And these ones are similar material. I think they're polycrystalline, but they don't have the same kind of texture on the surface, visual texture on the surface. They look like they might be monocrystalline, just one crystal. But anyway, each one of these you could wire them up together so that they make up a whole solar panel. So each one is called a cell, and then a panel would be a wiring of multiples of them. And so those are kind of fun. At some point I'll do those. This is a little solar panel. It's got 4 cells wired in series, so that will boost up the voltage, and then the area of the cells will give you the amperage. So wiring them in series gives you more voltage, and the size of the cell area gives you the amperage. If you can also wire them up in parallel, which would give you the same voltage but more amperage. So that's a little one of these. Sometimes on the back of these they have them labeled as to what they are as far as the voltage and the amperage. And this one here is mounted on glass, and it's a little it's about 2 inches by 2 inches, and it's pretty much a high output solar cell. On the back here it's labeled which one the negative is. So this one would be positive, this one would be negative. And so I got a stack of these waiting for a project. I'm not sure what the project will be for that. But the other day I came upon these in, let me just remove that. I came upon these in a dollar store, and they have this higher output cell on them. They're a little LED garden light, and when I was in the store I noticed that they light up during the daytime if the tab is still in it. So you can see that. Let me remove this base here. And so in the daytime, with this tab still in, it lights up. So that means that you can use this as a thing that runs a motor or runs an LED in the daytime. But you can also remove this tab, and when it's dark, so when I cover the LED up, then it will light up. So there's something going on in there. It's not just directly an LED. I removed these screws earlier. So it's not just a solar cell driving an LED. There's something else going on there. And that something else is two things. One is this battery that normally gets charged. So in the daytime, when sun or light is hitting the solar cell, then the battery is getting charged. And this circuit here, there's a little integrated circuit under this little blob here. This integrated circuit is got some logic to it that turns off the LED when the battery is being charged. And I think it also has a voltage regulator in it that boosts up the voltage, because 1.2 volts is generally not high enough voltage to drive an LED. And so basically this one gives you a charging circuit, and it also gives you a nighttime effect of electricity output. And this one over here gives you no charging and gives you, see if we can get this to go, and it gives you no charging, and it gives you a daytime lighting. So this is like having the solar cell hooked up directly to a motor or an LED. And depending on how close the light is to the solar cell, if you're only lighting one band, then it probably doesn't work so well. But if it's spread out a little bit like that, then you get a little better effect. So that's why it dims when you get closer, because you're only lighting one of the bands on the solar cell. And so there's a little bit of solar power and solar electricity. They're called photovoltaics. So it's light making voltage. And